Hey there, science fans! Have you ever wondered what stuff is made of? It's all about matter. Matter is anything that takes up space and has weight. That means you, me, your toys, even the air we breathe, it's all matter. Matter exists in different states. We have solids like rocks, liquids like water, and gases like air. The cool thing is, matter can change states. Think about ice melting into water. That's a change of state. Understanding matter helps us understand how the world works. From the smallest atom to the largest planet, it's all about matter and its incredible properties. So, get ready to explore the fascinating world of matter with me. Now, let's dive into the building blocks of matter compounds. Imagine a Lego set. You can combine different Lego blocks to create something new, right? Compounds are similar. A compound is formed when two or more different elements combine chemically. Elements are like the basic ingredients of matter, like hydrogen and oxygen. When they join together in a specific ratio, they create a new substance with its own unique properties. For example, water is a compound made from hydrogen and oxygen. When these two gases combine in the right way, they form the liquid water we drink and play with. Pretty neat, huh? Next up, we have mixtures. Think about your favorite trail mix. It's got nuts, seeds, maybe some chocolate chips, all mixed together. That's exactly what a mixture is. A mixture is formed when two or more substances are physically combined. Unlike compounds, the substances in a mixture don't chemically bond. They just hang out together, like the ingredients in your trail mix. Mixtures can be made up of different states of matter. For instance, salt water is a mixture of solid salt dissolved in liquid water. And guess what? You can separate the components of a mixture. Now let's talk about different types of mixtures. We have heterogeneous and homogeneous mixtures. Sounds complicated? Don't worry, it's pretty simple. In a heterogeneous mixture, the components are not evenly distributed. Think about a salad. You can see the different ingredients like lettuce, tomatoes, and cucumbers, all mixed together. On the other hand, in a homogeneous mixture, the components are evenly distributed throughout. Imagine dissolving sugar in water. The sugar molecules spread out evenly, so you can't see them individually. It all looks the same throughout. Colloids and suspensions. These fascinating mixtures are all around us, and understanding them can help us see the world in a whole new way. These are special types of mixtures where tiny particles are dispersed throughout another substance. The particles are so small that they can't be seen with the naked eye, but they have a big impact on the properties of the mixture. In a colloid, the particles are so small that they stay suspended and don't settle at the bottom. This is why colloids appear uniform and stable over time. Think about milk. It's a colloid of liquid butterfat dispersed in water. The tiny fat particles are evenly distributed, giving milk its smooth texture and white color. The fat particles are tiny and stay mixed, giving milk its cloudy appearance. This is why milk doesn't separate into layers when left standing. Suspensions are similar to colloids, but the particles are larger. Because of their size, these particles can be seen with the naked eye and will eventually settle out of the mixture. This means that the particles will eventually settle down if left undisturbed. You can observe this process in a simple experiment with water and sand. Imagine muddy water. The dirt particles are suspended in the water, making it look cloudy. Over time, gravity pulls the particles down, and they settle at the bottom. But leave it for a while, and the dirt will settle at the bottom. This is a great example of a suspension, where the larger particles separate from the liquid over time. Physical changes and chemical changes. Each type of change has its own unique characteristics and effects on the substances involved. In a physical change, the substance itself doesn't change. Its form or appearance might be different, but its fundamental identity remains the same. Think about cutting a piece of paper. You're changing its shape and size, but it's still paper. The paper's properties remain unchanged, even though it looks different. Melting ice is another example of a physical change. The ice turns into water, but it's still H2O, just in a different state. The water is just changing its state from solid to liquid. This change is reversible, meaning the water can freeze back into ice. Chemical changes are a bit more dramatic. These changes result in the formation of new substances with different properties. In a chemical change, a new substance is formed. This process often involves a chemical reaction, where the original substances are transformed. Imagine burning wood. The wood reacts with oxygen, producing ash, smoke, and heat. This is a classic example of a chemical change. A new substance, ash, is created, indicating a chemical change. Unlike physical changes, chemical changes are usually irreversible, meaning the new substances cannot easily revert to their original forms.